go down deeper? Pressure, right? And why the submarines are built so strong? To extend the pressure. Very good. Okay. So what we will be looking at today is activity. Right? I have a bottle here, students. I have this bottle here, and this bottle has been marked with 3 holes, right? And they are all alike. And I have now closed this hole with a surety. I have closed these holes with a surety, right? So we will observe how this water actually flows out of these holes as soon as I remove the surety, right? So you will see the variation in their pattern. Okay? We have 2 holes here. Okay, if you look at it like this, right? The 2 holes, from these 2 holes you can see the bottom one shoots the water at a greater distance. Right? Now, why is that so? Right? Because of the pressure. Okay? You can say it is because pressure in liquids increases with the depth. Right? You can see the weight, or there is more for this bottom hole. It has more weight of the water. That means it is experiencing more pressure, due to which it is shooting at a greater distance compared to the one which is on top, which experiences lesser weight than the bottom one. So it is not shooting at that greater distance, right? So if you look at here, it says number 1, the pressure in liquids increases with depth. So as you go down, the pressure increases. Now, the rule formula for pressure here is pressure is equal to density GH, rho GH. The symbol that we have here is rho GH, where rho is the density of a liquid. Then G is the acceleration of gravity, H is the depth of the liquid. Now, number 2 says the pressure in liquids acts equally in all directions. Okay. So we have an example here which says, what is the pressure 100 meters below the surface of seawater of density 1150 kg per meter cube? Okay. So we have used this formula, pressure is equal to density GH, right? So whereby you have 1150, you substituted here, then your gravitational acceleration is k multiplied by your depth of 100 meters. So which gives us our pressure of 1150,000 pascals. Now it is a very big digit, long digit. So what you can do is in the area we have learned about prefixes, right? So what we can do is the 3 zeros here, they represent kilo. So what you can do is that you can replace that 3 zeros with a k. So you can, in short form, you can say 1150 kilopascal, 1150 kilopascal. Right? So that is how you calculate the pressure in liquids. Now, I have an exercise here for you, right, students? It says here, what is the pressure 150 meters below? Now, our density that you can see I have given is the same. Right? Why I am to give you this question is because I am trying to show you here at different depths. Here we are at 100. At 150 meter, what will be our pressure? Is it going to be more than this, or is it going to be lesser? But according to our experiment that we have done just now, that as the depth increases, right, our pressure is going to increase as well, right? So here, let's do this activity. Everyone, just please quickly write this down and do the activity so that we can compare the pressure. question reads as, what is the pressure 150 meters below the surface of seawater of density 1150 kg per meter cube? Density E is equal to the density G. Finish everyone? Done? It will not take you long. Very simple. So can I have volunteer to come up on the board and present the answer? Napoleon? Check your work with your friends' work. Right? Check your answers. Check your units that you have written correct units. You can just give a brief explanation of that. Okay, listen students, he's going to explain the exercise.
Pressure is equals to density times gravity times height. So density is 1150, our gravity is 10, and our height is 150 meters. So we multiply them all, gives us 1,727,000 pascals. So you can divide them by 1,000 and get 1,725 kilograms.
Very good, thank you. Give him a clap please. Right. So you can see today we have a simple concept from water in a bottle. It has taught us a very powerful physics, and that is you have learned about pressure, and I think you will remember this for lifetime. Right? That as depth increases, pressure will always increase. Right? So that is our lesson for today, students. I hope you have learned our Cuban indicator, that was the basic properties of pressure in fluids. And the first part which said was as depth increases, the pressure increases, and the next part it says they are liquids act equally, pressure and liquids act equally from all the directions. The most important is the formula, which is rho GH, right? So I hope today's lesson was meaningful and you have done something important. Okay? So thank you all very much for cooperating.